All right, so welcome back, guys. So I put away the PPM motor, aka cone motor, for a while and brought back the Newman motor because there's a couple of experiments I want to do with this. And the reason I brought it back is because I really love this circuit by K Energy, the Opto circuit. Right now I have a two-pole rotor in there. And for that, you need to use a 60/40. Someone asked me, what does that mean, 60/40? Well, it simply means that 60% of the optical disc that breaks the light path has to be covered and 40% has to be bare. What I want to do though is I want to put this guy in there. And that's going to require a different, excuse me, a different disc. And I'll go over that in a minute. What I also want to do is I want to measure the output from this circuit when it's running different rotors in there. So first, let me set it all up. Basically, what I need to do is I need to jump these two. There's two connectors in the back, just like this. And I need to jump them so that it makes it one large coil. So stay tuned. All right, so set up with just this guy, and I'll try different settings. I'm getting 4 volts, a little bit over 4 volts back EMF. I know I can tune that obviously to get away a lot more, but this is a starting point. So we got 12 volts in, getting about 4 volts back EMF out. Let me adjust the commutator or the what do you call it? The disc to a different position. Hold tight. Yeah, so I'm getting a little bit more voltage out. I ever so slightly change the direction. Let me put the lid on here. Not the direction, but this. Yeah, the where the disc sits in relationship to the North and South Pole. Let me turn it a little bit more. Hold tight. Yeah, that seems to be even better. So basically the 60/40, if the North and South Pole were vertical like this, the 60/40 has to be vertical too. Either the 40 down or the 40 up or vice versa. I don't remember which I have right now, but whatever it is, it's doing a lot better than it was before. So let me check it out and see what it is. Well, here, I'll keep you guys on while I do it. Let me shut this off. All right, so we have the vertical up. It looks like the 40 end or it's vertical. Let me tweak it just a little bit more. I should be able to even get it to self start. Excuse me, I have my camera on a what you call it. That seems to be about the same, a little bit better. I'm going to, actually, it's going up a little bit more. Yeah, so it's hovering about 4.4. So hold tight. Let me put my lid on just in case. Yeah, it's about the same whether I have the fat part facing up with the pole or the fat part down. Well, actually, this one seems to be a little, no, it's about the same. All right, what I really want to do is I want to change out the rotor and put this monster 6-pole in there. I don't know if I need another brake on the other side. I don't think so. All right, stay tuned. Okay, so with the 6-pole rotor in place, I was told by K Energy, and I mistakenly thought I needed a 6-prong a 6-prong. Why is that saying 57 volts? The hell is that? Let me turn that off. That's wrong. And he said, no, you need 3-prong. So I'm going to experiment. I have one that obviously has much larger prongs, if you will, which will then interrupt the light for a longer period, a little bit smaller, a bone type shaped, and then just a straight shot. I think the larger one is going to work better. So let me get it together, find out why that thing said 57 volts. That doesn't make any sense. Maybe I should just get my, oh, it's millivolts. Okay. That's just from the, all right, it's got a little bit of a wobble in it, but that's okay. All right, let me get it set up. All right, so I've tried every type of 3-prong one. And I don't know if it's the rotor itself or I'm just not setting the circuit up correctly. But I'm not getting any real, I mean, I'm getting okay speed, but not really. I wonder if I need to connect a PWM. He's always telling me, connect a PWM for this particular circuit. I'm going to hook up my dual JL94 circuit and see what we get out of this. Stay tuned. All right, so here's the JL94 circuit. This side's producing 12 volts. This side's producing about 14 volts. See if I could get it on there one-handed. Yeah, okay, so 13 volts, and this one's doing about the same. But I'm not getting tremendous speed. I think it has to do with the rotor. Yeah, I think it has to do with the rotor. I think this Newman motor or this type of coil setup works best with either 2 or 4. But 6 is, it's just not set up for that, because whenever I do a 2 or a 4, I get tremendous speed. Like with this guy, I get a lot of speed. What I could do is I could take 2 of the magnets out of here, although I can't do it in such a way where it'll be even. I don't think I do have a 4-pole rotor, but it's too small for this setup. Let me think about this. Stay tuned. All right, guys. So welcome back. So I'm going to take a little break from the comb motor because I've been playing around with K Energies. He's a YouTuber who sells these circuits. This is a Hall sensor circuit, and I was playing around with it, and I was holding it like this, and I thought to myself, I need a way to mount it. Then I remembered I had a 3D printer, so I made a bunch of these. This is the one that seems to work the best. It's got a little curve to it, so let me... And you can see the light flashing from the output. It's over here. But yeah, it's funny because it works a lot better without the second coil. I'm getting some decent speed out of it too. I want to get my tack out, and I know it's not going super fast, but I want to try doing different ones. Well, you know what? I don't really need to do that. I can tell just by the sound and the wind. This is the one that has the fastest. Now, if I put it up here or underneath, I'm not sure if it'll go faster or not. No, it's about the same. Now that slows it down. That seems to be a little faster. Let me put the shorter one on there. Yeah, they seem to be about the same. But I love this circuit. And I just bought a PWN from them that plugs in right here. And so that should be here probably this Friday. Unfortunately, I'm not going to be here to get it because I'm going away. I'm taking my son up to Pinecrest and a couple of his friends. We do a father-son. I've done a father-son weekend with him. He's now 17. Ever since he was 4 years old, we've gone up to Yosemite every year for a long weekend. And now that he's a little bit older, we've kind of changed it up. I think last year or the year before was the last one that we did. No, last year I took him and a couple of his friends up. We're doing the same thing this year, but we're not going to do Yosemite. We're going to do Pinecrest. Anyway, I'm going to try some different rotors. I've got a tri-cube rotor I'm going to try. I've also got a quad cube rotor I want to try. So let me get this changed out. Stay tuned. All right, so I've got the quad cube. I have a feeling this one's going to fly. Oh, that's right. I put it in backwards. Or not backwards, but yeah. Yeah, that's working really good. Getting some strong output. Blinking for you guys, but it's solid for me. Yeah, this is a great circuit. I'm going to change the Hall sensor around a bit. I want to see if going straight in like this. Yeah, it's going to go the other way now. Yeah, it doesn't like it down there. Let's see what that'll do. Yeah, it likes it down there. Yeah, so the Hall chip either likes it up here, down here. That's a really good one. Let's try putting it I need to turn it around if I want it to go the same direction. Yeah, that's pretty good. Let's see what happens. If it'll do like a braking action, because it's going to want to go the other way. There it goes. I like that. That's kind of cool. Little Zen rotor action. Let me get this camera the right way. There it goes. All right, so let me try this one right here. This one's up a little bit higher. Not by much, though. Yeah, that one's good. Let me try it up here. That really puts out a lot of output when I put it down. And what I mean by that, the lights that I have it, the load on it lights up really bright. See that? See if I can see how much brighter it gets versus right there. All right, I want to try the try one now. Where is it? I want to try this guy. Not really sure how this is going to work. Let me turn this around. There it goes. Come on. Yeah, I love this circuit. I can't wait to get the PWM. I just got an email, Kay, that it's on its way. So pretty excited about that. All right, let's take this guy apart and try the try. And then I also have a dual one or a bi. Oh, and I also changed out the shaft because the shaft I had in there was a little bit lopsided. This guy right here. It's a crapshoot. Sometimes you get nice shafts, sometimes you don't. All right, stay tuned. So I added a third light and it was working really good. Yeah, like that. So that's, yeah, I got all three lights screaming now. That seems to be the sweet spot right there. Actually, that's the sweet spot right there for the output. I don't have, I thought I had one this small, or this low, I mean. Let me see. It's just not close enough, but it is doing good output. All right, stay tuned. All right, so here's the try rotor. Let's see what happens here. As I suspected, I had to put the hall sensor much closer, but it is working even though it's smaller. I should have made the try bigger. I'll probably reprint it, but it's giving me some decent output. So quiet. I tried to print a stand for it, but I messed up. I didn't make this little part, or a hall sensor clip or holder, but I didn't make this part wide enough so it could slide all the way through, or I didn't make it deep enough. But that works. I really like the little light on, the little LED that shows you every time it pulses. So quiet compared to some of my other motors. All right, I want to see if I can, here, let me take that off of there. Yeah, that's the optimal spot right there. Right there, just like that. If I turn it over, it'll reverse. And if I turn it back over this way, it will reverse. Which is kind of cool. All right, let me see what else I can do. All right, so I'm printing out another tri-rotor, but bigger, one that fills up the whole thing. And I was trying to figure out why I printed these so small. It's because they were prototypes for the stuff that I was sending over to PCB Way. Anyway, oops, it's a little bit too close. Let's see what this guy does. It's amazing, as small as it is, this giant coil still works on it. For a little rotor, it's doing mighty well as far as the output goes. Kind of cool. I tried the big round rotor. This guy, hold on. I tried this guy in a tri configuration, and it didn't work out too well. I'm not sure why, because the smaller tri worked out really well. Let's flip it around, see what happens. That's cool. All right, stay tuned. So hot off the 3D printer is this tri-coil. It's funny because back when I first started this channel, I'd be lucky if I could make one rotor a week. I would make it out of acrylic and PVC pipe. This is the third rotor I printed today. It's going good, but the optimal position for this guy is It's like right there. Yeah, so it would take, I'd be lucky if I could get one a week, if that. And again, I would build it out of acrylic and PVC pipe, and I would use crude Bedini circuits that I would make. Now I've got these killer circuits from different creators. I make some myself, but I prefer like K Energies or Sky Collection, and RD3DP creates some really nice ones too. And I create just the crazy rotors and different motors. I'm going to try this guy right here. Let me see what that does. Hold tight. Yeah, that's the optimal position right there. Yeah, with the tri-rotor, it's weird. It's hard to get a good position because I've got the two norths. What I could do is place the cubes in there where north and south are on the side of the cube instead of facing outward. Anyway, fun with Hall circuits. Thanks for watching.